Hello, I'm Mr. Perez, and today we'll be working with whole numbers and talking about different operations. By the end of today's lesson, you'll be able to multiply and divide by tens, hundreds, and thousands without using calculators. You'll be able to solve word problems with multiplication, division, addition, and subtraction, and you'll be able to check the reasonableness of your answers. We're going to start off easy with some multiplication by tens, hundreds, and thousands. 3 times 1, to start us off, is just 3. 3 times 10, pretty simple, that's 30. 3 times 100, well, I'm thinking about 300s. And 3 times 1,000, 3,000. Can you come up with a pattern rule on what we see on this side of the equal sign and what we see on this side of the equal sign? What's something that you notice? A little bit harder. What is 3 times 2? That's just 6. 3 times 20? That's 60. And 3 times 200? That's 600. And you guessed it, 3 times 2,000 is going to be 6,000. Is this the same pattern rule that we just saw? Now we're going to do some practice on our own. How many zeros are on each side of the equations? Remember our patterns from earlier. 5 times 1, pretty easy. That is just going to be 5. 5 times 10, again, pretty simple. That's going to be 50. 5 times 100, that's going to be 500s. And 5 times 1,000 is going to be 5,000. For 36 times 1, well, anything times 1 is going to be itself, so my answer is going to be simply 36. 36 times 10, well, I'm going to keep my 36 in the front, and following my previous patterns, I'm going to have a 0 in the back, making this 360. 36 times 100, well, that's going to be 36 hundredths. Let me make this look a little bit more like a 0, and this one too. And 36 times 1,000, well, that's going to be 36,000. Now, given what we've noticed so far, how many zeros do I see on this side? At the top, I have no zeros on this side of the equal sign. And on this side, I don't have any zeros on this side either. Here I've got 1 0, and I have 1 0 in my solution. Here I've got 2 zeros in my problem, and I've got 2 zeros in my solution. 3 zeros in my problem, 3 zeros in my solution, and the same follows on my 36 side. The number of zeros on both sides of the equations match. Let's practice with these numbers. Here, I've got how many zeros are on each side of each equation. 10 times 1, well, that's easy. That's 10. 10 times 10, from my multiplication tables, I know that's pretty easy too. That's 100. So, following our pattern, 10 times 100, that's going to be, that's right, 1,000. And 10 times 1,000 is going to be 10,000. So, 20 times 1 is going to be 20. 20 times 10 is going to be 200. 20 times 100 is going to be 2,000. And 20 times 1,000 is going to be 20,000. How many zeros do I have on either side of the equation? Over here, I have 1 0 altogether and I've got 1 0 in my solution. Here I've got 1, 2 zeros in my problem, and I have 1, 2 zeros in my product. I've got 1, 2, 3 zeros in my problem, and 1, 2, 3 zeros in my product. And on the last one, I've got 1, 2, 3, 4 zeros in my problem, and 1, 2, 3, 4 zeros in my solution. The same follows for my 20 times 1 side and 20 times 10. The zeros on both sides are the same. Now we're going to do some more practice. 2 times 2, very easy, that's 4. 2 times 20, still easy, that's going to be 40. 2 times 200 is going to be 400. And 2 times 2,000 is going to be 4,000. Remember to count all of the zeros in your problem when you do ones like these. 10 times 2, that's 20. 1 0, 1 0. 10 times 20, let's see, 1 times 2 is 2, and I've got 2 zeros in my problem, so I'm going to put 2 zeros in my solution. 10 times 200, that's going to be 2,000. And 10 times 2,000 is going to be 20,000. So now let's take a look at these. 20 times 2. Well, 2 times 2 is 4. And I've only got 1 0 in my problem that I didn't move over. 2 times 2 is still 4. And I've got 2 zeros that I've got to move over. Here I've got 2 times 2, that's still 4. And I have 1, 2, 3 zeros that I have to move over. And on the bottom one, 2 times 2 is 4. And I have 1, 2, 3, 4 zeros that I've got to have in my solution. Take a look at our numbers so far. Has our pattern changed yet? The first 2 numbers that are not 0 get multiplied together, and that answer comes first. All the zeros that follow them are then put into the problem. I'm multiplying just my front 2 numbers, 1 times 2, 1 times 2, 1 times 2, and then I add my zeros back into my solution. 2 times 2, 2 times 2, 2 times 2, and I keep adding the number of zeros back into the solution. Oops. Let's practice a little bit. 40 times 5. Well, let's see. 4 times 5 is 20. Now, even though I've got a 0 here and 1 0 here, my number's not right, because I know 4 times 5 is 20. This answer's too small. That's not reasonable. I have to remember to add this 0 back into my solution anyways. Any numbers, any zeros that are here that I did not write have to be written in. 4 times 5 is still 20. And I haven't written in my 1, 2 zeros yet. So my answer isn't just 20, it's 2,000. 4 times 5, that's 20. But I still haven't added in my 1, 2, 3 zeros for my problem, so I've got to tag those on to the end, making my answer 20,000. 4 times 5 is 20. 1, 2, 3, 4 zeros. If I only put 1, 2, if I only had 4 zeros, that's not quite right. I have to remember that 20 was my answer, and there were 1, 2, 3, 4 zeros I've got to put in behind the 20. Here's my 20. 1, 2, 3, 4 zeros behind my original 20. Like this. 40 times 6, that's 24, pretty easy. Plus the 0 from my problem. 4 times 6, 24. Plus 1, 2 zeros from my problem. 4 times 6, 24 with 1, 2, 3 zeros from my problem. 4 times 6, 24 with 1, 2, 3, 4 zeros from my problem. Here is some independent practice. I'd like you to do these on your own, so pause the video here, and when you come back, we'll check our answers. Here we go. 2 times 10 is going to be 20. 2 times 20 is 40. 2 times 30 is 60. 2 times 40 is 80. And 2 times 50 is 100. 10 times 10 is 100. 10 times 20 is just 200. 10 times 30 is 300. 10 times 40 is 400. 10 times 50 is 500. And here we are, 20 times 10. I've got 2 zeros in my problem now, so my answer is not just 20, it's 200. 20 times 20 is 400. 20 times 30 is 600. 20 times 40 is 800. And 20 times 50 comes out to be 1,000. One 100 times 10 is 1,000. 20 times 100 is 2,000. 100 times 30 is 3,000. 100 times 40 is 4,000. And 100 times 50 comes out to be 5,000. Boy, is my handwriting terrible or what? So really, we've come up with these rules. Find the number of zeros at the end of each number in your problem. Multiply the digits that come before the zeros, and then return those zeros back into the product. With 400 times 300, we find the number of zeros at the end of each number. We've got 1, 2, 3, 4 zeros, so we have got 4 zeros. We're going to multiply the digits that come before the zeros, so 4 times 3, that comes out to be 12. And then we're going to return those zeros into the product. So my 12 becomes, with 4 zeros, 120,000. Let's do a few more. Find the zeros, multiply to find your answer, and then put those zeros back in. Go ahead and pause the video, do that, and when we come back, we'll check our answers. Alright, here we go. We've got 4 zeros. We multiply 4 times 1 to get 4. And when we return them, we have our answer of 40,000. With 50 times 20, I've got 3 zeros. 5 times 2 is 10. And I've got to add those 3 zeros back on behind the 10. So my answer becomes 10,000. 800 times 2,000. I've got 5 zeros. 8 times 2 is 16. And so if I put my 5 zeros behind my 16, I have 1, 2, 3, 4, 5. I have 1,600,000. In our last example, 600 times 600, I've got 4 zeros again. 6 times 6 is 36. And with 4 zeros behind it, my answer becomes 360,000. It's now turning the page. Here's some independent practice for you to do on your own. Go ahead and do these problems, and when we come back, we'll continue. Alright, here we are. We're dividing by tens, hundreds, thousands, and more. We're going to take away all of the shared zeros when we divide, and then just divide normally. Very simple. Let's go ahead and try this. When I take 45,000 divided by 500, number one, I'm going to remove all of the shared zeros. If I've got 2 zeros over here and 3 zeros over here, I can only get rid of 2 zeros on both sides. So now my problem is 450 divided by 5. If I divide normally, let's see, I'm going to do it like this because it's a little bit easier for me to see. 5 goes into 450. Let's see, 5 goes into 4, no times. 5 goes into 45, 9 times. I'm going to do my long division subtraction just to make sure that I'm not making any mistakes. 45, take away 45 is 0, but I'm not done dividing yet. I still have a 0 over here. So 5 into 0, 0 times. My answer is 90. We're going to do these together. And remember, all we're doing is taking away our shared zeros and then dividing normally. So our problem becomes 1200 divided by 2. If I do 12 divided by 2, that's 6. And then I've got 2 zeros left in my problem, so I'm just going to transfer them to my answer. 27 divided by 90. I can get rid of that 0. I can get rid of that 0. 27 divided by 9, that's just 3. 9,000 divided by 300. I've got 2 zeros on this side of my division sign. I've got 2 zeros on this side of my division sign. And so my problem becomes 90 divided by 3. 9 divided by 3 is 3. And then there's a 0 in my problem that I didn't cross out, so I'm going to bring that over to my solution. 4,000 divided by 500. I can cross out these 2 zeros because I've got 3 zeros on this side, so I can get rid of 2 of those. 40 divided by 5. That's easy. Multiplication table tells me that's 8. 2,100 divided by 70. I've only got 1 0 and 70, so I can only get rid of 1 0 over here. 21 divided by 7. That's 3. And then I've got a 0 in my question that I didn't cross out yet, so I'm just going to carry that over into my answer and make that 30. 63,000 divided by 9,000. Let me get rid of 3 zeros over here and 3 zeros over here. So I have 63 divided by 9. That's just 7. And on my last example, I've got 3,200 divided by 800. Here I'm getting rid of these 2 zeros and these 2 zeros. 32 divided by 8 is just 4. And then I've got a 0 I didn't cross out, so I'm going to just carry that over into my answer. And it becomes 40. Go ahead and do these independently on your own. Remember to cross out any shared zeros. So for example here, I can get rid of both the zeros in my problem. I've got a 0 over here, a 0 over here, they match, I can get rid of them. Here, I've got 3 zeros and only 1 0 here, so I can only get rid of this one and the one that matches. And I'll still have 2 zeros that I have to deal with in this problem. Go ahead, divide normally, and when we come back, we'll move along. Alright, here we go. Working with word problems and the 4 operations. Now, just to review, the 4 operations are addition, subtraction, multiplication, and division. Your keys to success on figuring out how to do a word problem is to read the problem. Think about what the problem is asking you, and choose the right operation for the problem carefully. Then solve your problem and check for reasonableness. Now, this is the only real steps that we can kind of discuss here, because it's difficult to tell with a word problem what operation to use when. There's no surefire way to say that every problem that says altogether is going to be addition, because sometimes that could be multiplication, or it could be division. There's just no code words, there's no easy ways to do it. Not really, not if you're going to get it right every time. You really need to read the problem carefully, think about what the problem is asking you to do, and then choose that right operation very carefully. Let's go ahead and give this a try. Here's our sample problem. Maggie wants to plant sunflowers in her garden. She has 320 sunflower seeds. She has room to plant 40 seeds in each row of her garden. How many rows can Maggie plant? All right. I'm going to read this problem carefully and think about what the problem is asking me to do. Maggie wants to plant sunflowers in her garden. She has 320 sunflower seeds. Okay, so that's a lot. And she has room to plant 40 seeds in each row of her garden. So it's going to ask me to take 40 out of this 320. Each tells me I'm going to be doing it over and over again in the rows of her garden. So how many rows can Maggie plant? Alright, if it's asking me to split up 320 seeds into rows of 40, I'm splitting a large group into smaller groups. I'm going to choose the right operation for this problem very carefully. Splitting up a large group into smaller groups sounds like division to me, so I'm going to use division to solve this problem. So 320 divided by 40, I've got a shared 0 here, I've got a shared 0 here, and that becomes just 32 divided by 4, and that's 8. So now I'm going to check for reasonableness. Did I do my math correctly, my arithmetic? I did. I got rid of the shared zeros. I followed that rule. And 32 divided by 4 is 8. Does my answer make sense? Does it make sense that she would plant only 8 rows of sunflower seeds? 8 does sound reasonable. She's not planting hundreds of rows, and she's not planting just one. So my answer doesn't seem too large or too small. It seems just right. So let's do a few more. Remember, we're going to read, think, and choose our operation carefully. Alice loves playing video games. Each game costs about $50. If she wants to buy 4 games, how much money is Alice going to need altogether? So each game costs 50. She's going to get 4. How many is she going to need altogether? Well, this doesn't seem like addition, because I'm seeing how many she's buying 4 of these games. It's definitely not division, because I'm not splitting anything up into groups. This seems like multiplication. So 50 times 4, 5 times 4 is 20. I'm going to add that 0 in my problem back into my solution. And so $200. Now when I check this, $200 seems reasonable. If she's buying 4 video games, $200 sounds just about right. Seismosaurus was about 150 feet long from nose to tail. Albertosaurus was much shorter and comes in at about 30 feet long. How much longer is a Seismosaurus than Albertosaurus? So this is asking me to see what the difference is between Seismosaurus and Albertosaurus. Difference is a subtraction thing. So I'm going to do subtraction. I'm going to take 30 away from 150. And I get 120. Given that Seismosaurus was 150 feet long, and I'm taking away from 150 only 30. 120 does seem pretty reasonable. That doesn't seem like a crazy answer. Porter's stamp collection grew to 450 stamps. Each page of his stamp album could hold 30 stamps. How many pages will Porter's stamp collection cover? So let's see. I have a large group of stamps, 450. I'm going to see how many each page will hold. So the operation that I think I'm going to need, if I'm splitting one large group up into small ones, is division. If I get rid of that 0 and that 0, my problem becomes 45 divided by 3. So I'm going to write it this way so I can see that easier. 3 goes into 4 one time. Take away 3. And I have 1 left. I'm going to drop that 5 down. 3 goes into 15 5 times. So my answer will be 15 pages. 15 pages in a stamp collection book doesn't sound outrageous. If there was 150, that would seem like too many, especially for just 450 stamps. So my answer does seem pretty reasonable. Here are 4 problems for you to do on your own. Remember, when you're doing them, take the time to carefully read your problem. Then think about what the problem is asking you to do. Is it asking you to put groups together or separate groups? Is it asking you for a difference? Is it asking you to make groups of something, or is it asking you to see how many times something is? Choose your operation carefully and then do your math. Go ahead, pause this, work these 4 exercises, and when you come back, we'll finish up. Alright, today you have practiced and can now multiply and divide tens, hundreds, and thousands without using calculators. You can solve word problems with multiplication, division, addition, and subtraction, and you can check the reasonableness of your answers. This is Mr. Perez, and this has been Working with Numbers. I'll see you next time.